I had this VCR in for service a few months back. It was the Sony Beta machine that the gear had broken and it would not thread the tape. I'm sure you guys remember it, SLHF300. Well, it worked for a while, but like all old electronics, well, you never know how long they're going to run, and this one ran for several hours and then decided to create a new fault for me. So let's see what we've got. Got an SLHF300 in for service. Let's see what this one's up to. So this is one that I had in a few months back. It had the gears broken on the loading, and apparently the drum doesn't work on it now. The fellow that owns it said he transferred multiple tapes, and right in the middle of one of his tape transfers, the drum stopped. The drum is certainly spinning, but it's not spinning up to speed. There's virtually no torque. Look at that. So we have this could be a motor problem. This could be a drum motor problem on this one. This one may end up having to get the drum motor out of that 900, which was it's another machine from the same fellow. Because it's got voltage, it's spinning, it's just not spinning right. And if I stop it, you see that it's like it's missing a phase. These are a three-phase motor.
Actually, this is a two-phase.
So we have a problem. It's either going to be the drive IC that's gone bad, or one of the coils has gone open on the motor. But definitely it has a problem with the drum servo or drum motor itself. This is the problem with this old equipment, right? You fix one problem, and then not far down the road you have a completely different unrelated problem, and these machines start to become a money pit very quickly, because I can't guarantee anything that I haven't repaired. Even that, it's hard to guarantee even things that you do repair, because when you're dealing with equipment that's old, a lot of times you're putting in parts that are also old, or repairing parts, like when you've got broken gears and so forth, because you can't get new parts. So it's very tough to repair this old equipment and tell someone, well, yeah, you've spent money on it and it's going to last you another 10 years. That's never the case, because you've got a bunch of other old components, other parts that are just waiting to fail, and you can't change them all. I can hear the people out there saying, just recap it. Well, caps aren't the only thing that fail. I'm just opening this board up so that I can get to the actual motor itself. These have got plastic clips on here that actually open up and will hold the board up. At least they're supposed to. These plastic clips, when you flip it up, they actually have little locks on them to hold the board open so that you can work on it. So here's the bottom of the motor assembly. We'll just remove the plastic covers that cover the capstan and the drum motor, so we can inspect under here. These have both a Hall effect and FG sensors for speed and position. So it could be one of the sensors for the position of the motor itself, which are under here.
That Hall effect device is usually the one that fails, but when it goes bad, the motor won't even attempt to spin.
Common failure on a lot of these was the circuit glue they put on got corrosive and damaged the traces.
Or I should say conductive, and went leaky, what it did.
So it could very well be that that's where our problem is, or be anything actually. It could be the servo chip too, for that matter. But you can see it's not wanting to spin. It just sits there and rocks back and forth.
This symptom here actually is more along the lines of that FG sensor that's failed, or the drive IC, or the drive transistors, one of the three.
It's fed over here. Yeah, it still doesn't want to spin even without servo control. It doesn't want to turn. I guess the first thing I need to do is I need to remove the rotor slot screwdriver on one side to hold the shaft from turning, and then a 7mm socket. There we go. That was tight. The magnet out of there. Okay, I'm just going to put the magnet for safekeeping away from tapes and anything magnetic can drop into it. Biggest problem on these is the Hall sensor down here. The connections go bad on this Hall sensor. This is what determines that the motor is actually rotating to tell the circuitry when to switch to the next coil. Of course, it could be the motor drive circuitry as well, but usually, or quite often, it's this little sensor here. You get all this crud that's already forming around there. You see, whoops. You see all the crud that's forming around here? That's circuit glue. And that is a real issue on these devices. Lots of them failed. Lots of them failed over the years.
It goes conductive, but it can also go corrosive and eat away the leads. In this case, it hasn't broken the leads.
The Hall effect has not damaged itself. I don't know whether I'm blocking the shot with my headgear here or not. I can't see this monitor. So if I'm blocking this with my head, then too bad. I can't do much about that because I'm trying to work on this thing while observing through magnifiers what I'm doing. The drive IC is, if I'm not mistaken, it's on the board directly behind this. And the only way to really inspect this would be to pull the drum right out and pull the whole motor assembly off the lower drum. But I just want to check this first and see whether we'll put the rotor back on and see whether it will spin. Otherwise, I'm going to have to go to the next step and pull the motor right out. Position of this is not critical because it's not, the phase is not controlled at this point. The phase is controlled by the pulse generator, which is actually on the drum itself. This is just the FG for detecting the motor is rotating, and so that it knows when to switch the phase of the motor. It detects the magnetic field. Okay, I'll plug this thing now in again and just see whether the thing's going to spin or not. Of course, it's going to unload first and then reload. Okay. No. Well, it's spinning slightly, but it's not spinning right. And it's still doing the same thing. So I think we got a problem on the actual motor circuit itself. So that means I'm going to have to pull the drum out to inspect any further. So we'll just remove the tape. and pull the drum motor out. Check that out. To do that, I'll just unplug the cords that connect it to the, first of all, to the preamp, which is over here, and the servo circuit. There's a couple cables that go over there. Basically, there's the feedback circuit that tells it speed up or slow down, and then there's the power circuit, and then there's the signal line that says turn the drum on or don't turn it on. So we've got this one here, which ends up over there. See, that drum out of that 900 might end up, we may end up having to use parts from that to get this one going. If it's the drive IC, for example, that's bad, which I don't know at this point where the fault is. There's a fault somewhere. Could be a bad connection. It could be the drive IC. Here's the other cable that goes down here. This one plugs in over to, I think it's this red connector over here. So gotta cut this zip tie. Undo this one, drum drive. The reason I'm immediately going to the drum motor as opposed to other servo circuits is because the way it's acting up. If it was just spinning or not spinning, if it wasn't turning at all, or if it was spinning the wrong speed, then yes, I would definitely be looking for something back in the drum circuit itself. But because it is spinning, it's just not spinning at the correct, or I should say the correct speed. It's just not spinning properly. Like it sits there and does this. That's indicating a drive problem. On these two cables that feed back, what we have here is we get a couple signals on here. We have an FG signal, and we have a PG signal, and we have a drum servo circuit. So basically, one wire's got power that feeds the power to the drum motor itself. One wire's got a speed control which varies up and down to either speed up or slow down the drum. I believe it's on this gray wire here. And this one here, these are the PG and FG pickup coils that feed signals back to the servo IC. One of them is fed, one picks up its signal from the top side of the PG pulse, and the other one is the frequency generator. Anyway, those are removed. I can remove the 3 screws here that hold the drum in place, and then we'll drop the drum out from the other side, and that way we can take the drum apart and see if I can get the drum to work properly. So these here screws here are spring loaded, so they keep the correct tension on the drum. They do have washers on them too, so you got to make sure you get the washers out when you remove them, otherwise they'll fall out. And when I remove the third one, I'm going to have to hold the drum so it doesn't fall out. My bench isn't level. Everything's rolling to the back. Okay, I'm going to hold the drum in place with my other hand here and take out this one last screw, and then the drum actually lifts out from the other side.
I now have to remove the 2 plastic guide
I guess both
locks.
of them have to come off because there's a spring on here as well.
So that I have clearance to remove the drum.
Okay, now I can lift the drum out. Carefully, that is. And it should lift right on out. Just like that. Okay, I can put that out of the way. Okay, so here's the motor assembly on the bottom. So if I remove these other two screws here, I can actually remove the motor assembly so we can see the drive IC and everything else that that is where the fault is likely going to be is on the drive IC itself. Again, to do that I have to remove the rotor again, because with the rotor on there we aren't going to be able to remove the actual stator assembly. So once again the rotor comes off. This time though it's a little easier because I can just undo the screws and lift it off as one assembly. Pop apart a clip here. Thing off just like that, and there's the control. These other, as you can see, this other cable, this is the PG pulses that are on the PG pickups that are on the lower drum, and the video heads, these are the rotary transformer that take the video signal up to the video amplifier, so we'll move that aside. This is the motor assembly. We'll just remove this magnet again and get it out of the way for now. Okay, here's the other side here. As you'll notice, there are a couple capacitors on here and the drive IC. And this is where that FG signal generator goes in. So we've got our speed control, and it's controlled through the shielded line here. The red one will be power to drive the IC on here, which is what drives the motor. We're only getting a couple of the phases. We could have bad caps on here for sure. Some of these little caps could have failed, or it could be a connection between here and the coil. The motor itself supplies power through this connector. So power from the motor goes through these three here. This is what connects to the coils on top. And this is the Hall effect, which tells the IC what position the motor is in so that it can generate the phases. And it could even be a connection problem on here. I turned on the radio today and I see that we've lost 2 radio stations here in the Lower Mainland. I'll play you what they're playing right now if I can tune them in here. So this is what we're greeted with. It's an AM station. Both of them are AM stations, and it doesn't come in very good here in the workshop. But they've just been playing this generic same song, and then an announcement comes on that they've shut down. That was Bell Media today, canning a bunch of workers and shutting down a bunch of radio stations. Here we go.
To BMN Bloomberg 1410. As of 8 a.m. on June 14th, CFTE AM 1410 is off air. The realities of AM radio in the broadcast media landscape have made this change unavoidable. We want to thank our advertising partners, sponsors, and everyone who has contributed to this station over the years. And we especially want to thank you, our listeners. Thank you for welcoming AM 1410 into your homes, cars, and lives for so many years. Thank you, Vancouver, for listening to CFTE AM 1410.
Sounds like they've turned their power way down. And it's just going to play that same music again. Oh well, it was inevitable. With so many car companies getting rid of the AM radio in their cars, I guess it was inevitable that they were going to start shutting stations down. But we lost 2 stations here today. One was Bloomberg Radio, which was always an interesting station to listen to find out financial news. I used to listen to that one on a regular basis. The other one was a comedy channel. It used to be a sports channel, but they changed to a comedy format a couple of years ago. And they're now gone as well. But anyway, that's what's happening in Vancouver radio. A bunch of people lost their jobs, and we don't like to see that, but that's what's going on. So now there's even more spectrum on the AM band to DX those stations that are in the distance. So I'm looking forward to that, getting my big antenna. Well, I got to I use my ham radio for, but I do a lot of AMDX just to pick up stations from distant cities, and now there's 2 more clear channels to listen on. So that's the only benefit there. Anyway, back to this piece of crap. I'm just going to give these connections a close inspection. We'll check these caps out. They are all 1 microfarad, I believe. 1 microfarad, no, 0.1. It's 1 or 0.1. There's 2 1s and 2 0.1s. Right here, these 2 are 0.1 and these 2 are 1 microfarad. And they could cause a problem, but generally they wouldn't cause this type of a failure. But we'll check them. We'll check them, see how they are, and change accordingly. But you guys know what I'm thinking, right? You know what I'm thinking. If this control board is indeed FUBAR, I got another one sitting like right behind me. I didn't bother to put it back in its box, but I do have another one right behind me that I can certainly steal the control board out of to get this one running if necessary. But we'll check this out first, see whether these caps are measuring what they should be measuring in terms of microfarads. These are too low for testing ESR on it. Doesn't work on caps that are that small. So we'll just check these for microfarads. 2.5. I think we're probably okay on that one. These are rated at 1 microfarad. 2.6, so it's got some capacity, that's for sure. These ones are 0.1, so they're coming up 0.5. And that one there is also coming up 0.5, so I would say that the capacitors are okay. So we can certainly check the resistance of the coils to make sure that there's no open coils here. It's actually, I think it's a 2-phase. Well, it's 2-phase. There's 3 wires, but there are 3 sets of coils. They're connected. They're just 2 coils, and like there's three coils connected per run. Right, so the phase is altered between the 2 of them to spin the motor around. So you've got 2 phases making up the 3 coils, if that makes sense. Anyway, we have a common, and we have 18 ohms on one, and then 18 ohms on the other. So we know that there's continuity here. Now both of these are controlled and fed from transistors on the other side of the board here, which are driven from the drive IC. So let's just check the transistors out and make sure that we do not have a transistor that's failed. So here's one transistor here. Oops, I put this into diode test mode. Let's check this transistor out and see whether we've got a transistor that's bad. That's looks like we're okay there. No. Okay, base, and then this is we're probably also reading some other resistance in the circuitry. There's our 2 junctions there, and an emitter to collector. Okay, no shorts. It might be the IC that's bad on here. I'll go over these connections just to make sure there's none that are bad, and then we'll try it outside of the machine. I can load the machine up without a drum in it, without a tape in it, and plug the drum in and just see if it will spin, because it doesn't need to be in the machine to do that. This one here looks like it could be questionable, as is this one. A couple of these connections on here look kind of questionable. That's why I'm going over it. We'll try this before I swap it out. I'll try this and see whether this will work. just on the radio right now, it said that Vancouver is the second most expensive city in Canada to live, next to Toronto. Never have figured that one out myself. Never. No. Considering that's where I live. Talking about the Stanley Cup last night in Las Vegas. Local guy that plays for the team from, I guess, Aldergrove, I believe, is where he's from. So I guess the Stanley Cup will be coming to BC for a bit here in the next month or so. So basically, I'm just going to go over this entire board. The time it takes. But a couple of these connections, when I heated them up, I saw the other side of the component moving. So it's like, okay, maybe they weren't great. Maybe this is the problem. It certainly would create a fault if there was a connection that had gone up in resistance and wasn't passing a signal. That would certainly cause problems. I had a cat that's screaming at me from the other side of the door. You can probably hear him. He's quite annoying. I know he's not hungry. He wants to play fetch. Okay, I'm going to throw this back together right now, and I'll load the mechanism up. I won't reinstall the drum, I'll just have the machine thread itself, and that way I can test, make sure that everything is going to work as it should. If the drum spins. If the drum doesn't spin, then I gotta look for another drum drive IC. It's really that simple. That's about all the only options I've got. So we'll just bring the wires back around here again and remount the motor assembly onto the base of the drum. Okay, so the machine powered up. I've got the machine threaded. You can see the guide pins are up because it thinks there's a tape in here. When I push the play button, the motor on the drum should start to spin. And it's still doing the same thing it was doing before. Therefore, we know that the drum motor has a problem. So let's go get the other one. Swap the lower drum, or lower the motor assembly from the other machine, and see if we can make this one work. Providing that the other one's not damaged, because it was spinning too fast, but I have a feeling it was the IC, the servo IC, because that's the one that had the water damage. Alright, so we're back on this one. Let's strip. Well, let's not strip, let's just strip the mechanism. How does that sound? So I got to pull these. You see, I've also got a SLHF300. I don't know if it was the same one that I had before that had the bad heads. That had the SP or the Beta 1 heads were bad. So I don't know if he sent me that same one back to do a head swap on or not. I know I have another machine here, and it might be the 750 that's got the bad video head for Beta 1. So if that's the situation, then the head might come out of this one. The disc might come out of this one and go into the 750 if it's the 750, because I'm letting the cat out of the bag. The box it's in is the 750 box, but whether it's that same machine or yet another one, that I don't know, because the fellow that owns this has lots of machines. And if I can steal parts out of this machine to get the 300 to work, then it's a win-win situation. Then what he spent to get a parts machine won't be money wasted. Be money well spent. Because, as everyone knows, the only way to fix these old beasts these days is to take parts off of other machines. That's really the only way to fix them, because you can't get them anymore. They haven't made the parts for 30 odd years, 40 years. This machine would be what, about 1985, I think, 85 was when, or 86. This was the first Super Beta machine that Sony released, and I have one. Mine's got a seized drum, though, because the drum from my 1000 seized, and that's another story. The 1000 that the drum seized on was a machine that I should have never bought. I bought it at A&B Sound after they had gone out of production, and they sold me the display model. And well, when I got it, I don't care about that. When I got the thing from them way back in probably 87 or so, it was 87. But anyway, when I bought the 1000, the drum was making a noise. The drum motor was making a noise. I got shh whenever it fired up, and it would go away after a few seconds. Like, it would always start up with a really noisy bearing. And I shouldn't have bought the thing. I should have taken it back at the time. But I wasn't thinking like that. Okay, well, it's got a warranty on it. If it breaks, it'll be covered under warranty. And of course, the time I used it as an editing machine, I used that machine. I think that was my playback machine. I had the other 1000 that I was using as the editor, and I was using it as a playback machine because it had the control, not time code that it had, but it had the control track timing, so it was accurate to a couple frames. Anyway, I never took the thing back, even though, as I say, I probably should have returned it when it was new, or newish. There's this wire going. It's going around here somewhere. And of course, the problem over the years got worse. But I didn't use the machine a lot. I used, as I say, I used it as a playback machine, and then I stopped editing on Betamax and moved up to more professional formats. So the machine sat, and it sat, and it sat for years. Actually, I think what happened on it was the regulator failed on it, so I just kind of let it sit, because I had another one that worked. So I just kind of let it sit, and then one day I decided to fix it. So I ripped the regulator out of my 900 and put it in the 1000 and got it working. And I still had the noisy bearing problem. But at this point, because it had been sitting for all those years, it only ran for a few hours, and then it just seized up completely, and completely locked up. Like, you couldn't even turn it by hand. So I ended up pulling the drum out of my 900 because I'd already robbed the regulator out of it anyway. So I ended up pulling the drum out of my 900 and using that to replace the entire drum. It doesn't have flying erase heads, though. It's just a 4-head machine, but it works. So now I've got two SLHF 1000s that are functional. One that can edit and one that can play. Here's this sad excuse for a drum. As you can see, this one here is kind of marked up. Anyway, we're looking for the motor on this one, so let me get rid of this chassis for now. I bet you this one won't be nearly as tight as the other one. There we go. Do that clip, and now I should be able to just lift this off like that and set the head drum aside. We're going to swap out the entire motor, and I'll even leave the existing stator on there. It doesn't need to come off, or the rotor I should say. Just leave that entire thing intact and just undo this one, undo the screws, and just swap it over. Fingers crossed it's going to work. If it doesn't work, then we're back to square one. Well, it might not work. It might spin up to 20,000 RPM if the motor on this other one was bad. Okay, so this is the one I'm replacing. Oh, now he's clawing at the door. He'll scratch his way through here in a minute. Silly cat doesn't know he's not allowed in here. For his own safety. There's too many things he can get into in here that would be harmful. But also I've got the door open, so I don't want him running out onto the street. Okay, let's go grab the other chassis and see whether it spins. Okay, so I've got it plugged in with the new motor assembly on there. Let's see whether it will spin. Play, where's play? There's play over there. Sounds like it's spinning to me. So we'll reinstall it and see if I get a picture. Careful not to touch the head chips here. And just fit the drum back in. Like that. And then get the screws in from the back side to hold it in place. Okay, now I got the head rotary transformer to plug in over here to the preamp. And the motor control and the FG control over here. Now we can test this and see whether it works. Fingers crossed everything's going to play back properly. Gotta get the guides back in. They go in only one way. Is it this way? Is it that one? I think it was this one. The middle one here that was down. Like that. And then this piece goes over top of it. It sits in the holes. I don't have a picture. It almost looks like a bad head. It sure looks like one of the heads may have gone bad on this one. Like there's no output from one of the heads. I will have to investigate and see. Gonna check the head drum. See whether the head has been damaged. I don't recall touching it, but it could have been damaged when it stopped spinning, when the tape was being played, and the tape the head drum wasn't spinning. The tape being pulled around the head drum with the motor off could have damaged one of the heads. That's what I'm thinking. Again, I couldn't test it until I got the drum running, but it sure looks like a bad head. I'm hoping that I might have a replacement because I've got a couple of old machines. So I'm just going to pull this one off here and just give it a visual and see whether I can see anything damaged on it. I'm looking for some screwdrivers here. Got to remove this top. Just give this a scratch so we know where it goes. That way we can reassemble it and remove this first of all. Remove the When I had the drum out of this machine, I was very, very careful not to put my fingers anywhere near where the head chips were, and not to apply any excessive pressure to it. So I don't think I caused any damage to the head drum. If the head chip is shot, it would have been due to the tape being stationary and being pulled around over the head with the head stationary. But let me just pull the head drum out so I can get a closer look at the chips. Got unsoldered them here, and then take out the screws, and I should be able to just lift the head disc off. Fortunately, on these ones you don't have to do eccentricity or dihedral. That's what the beauty of this particular design was. It was just basically plug and play. You undid the two hex keys that hold the head in place and swap the drum over. The older units you had to do eccentricity on, but not these ones. I got rid of the cat by going and throwing a stuffed toy for him. So now he's going to go play with that for a while. You know, leave me alone. Nothing is more annoying when you're trying to concentrate than having a cat sit at the door howling at you, wanting attention. So this should just lift off just like that so that I can inspect it. If you look at the bottom of the drum, there's the little magnet for the pulse generator. You got your A and your B head. And if we look closely at this head here, this head looks like it might be damaged. Looks like there's a piece missing from it. Right. You look on this side, you see this little metal piece here. This is actually a head of the head that is supposed to keep any debris that might get into the track, like if the tape were to snap and get into the track. This is designed to protect the head from getting hit. This one here looks like it's missing on this side. This head here is likely damaged. See if I can find another one. I've got another one here in another machine. Let me just go and take it out of another machine and see if we've got another head I can swap in there and try that and see whether that's going to work. But I think the head is damaged is what's happened, and it probably happened when the machine shut down and the tape was being dragged around over a stationary head, because that would cause the tape being pulled at an angle would cause a vertical vertical stress, because the head is designed to be spinning, right? And if you stop it from spinning, the tape being pulled around under tension could certainly put excessive stress on and could damage the actual head itself. And I think that's probably what happened on it. But let me go find one from my stock of old machines. Okay, I've got another one here. I don't know what shape this one's in. This is the machine that the drum was seized on. This is an SLHF300, and this one came out of an SL300. So I don't know if there's any other differences between the two of them. I'm going to drop this other head drum on and see whether it will work. I just want to see whether I get a picture. So we'll just attach this head drum. I tell you, it just really gets me going here. Is I get a call from the Yellow Pages. Oh, we want to give you a free ad for your business. I don't want a free ad. I don't want to advertise. Right? It's oh, it's free. I don't want it. The next thing you know, I got a free ad. Right? So I'm not buying advertising. Well, then I get Google calling me, wanting me to advertise. I'm not advertising. I'm not running a business. Right? And I just get a call now. I talked to someone about purchasing your commercial insurance for the business. No, piss off. There is no business. I run an office out of my house. Everybody's out there wanting something, wanting money. I tell you, it drives me crazy. Okay, that should be good enough for testing for now, and see if I get a picture. So the first head I put on from an SL300, it was one that was unknown condition because the wires were not soldered down, so I thought maybe I'd swapped that and stolen it before, which it turns out that I had, because this head's worn. I had another old Beta machine. This was an SLHF300, a 3-head machine. I just swapped the head again. We're only using 2 of the 3 heads. One of them's not connected. Let's see. I didn't show you guys the procedure of doing that again because didn't need to, but let's see whether I get a picture on it this time. Indeed, I do get a picture. So what happened on this one, when the drum motor went out on it, what happened was, got to adjust the tracking and stuff on here still. I'm not quite set up. But what happened when the drum motor stopped, stop that so I don't have that music playing. What happened when the drum motor stopped? One of the heads would have been in contact with the tape. The guy that owns it's trying to make it work. He's fast forwarding, he's rewinding. The tape going around the head without the drum spinning is going to cause excessive tension on the head chip itself that's stuck against the tape, especially if it's stuck somewhere midway like this where the tension would be high, especially on a rewind or fast forward. The tape itself, because it's going at an angle, it's going down the drum, would have lateral, or vertical, I should say, vertical stress, which likely damaged one of the heads. And that's why I put the new drum motor on, got the thing spinning, had no video signal. Looked like a bad head because it was a bad head. So now I've had to put another head on this machine. I think this is the right one. Just double check to make sure that I've got the A and the B connected. But because this is the A head, obviously, but this one here has got an A and a B. A second A for clear freeze frame, which we don't want. And they're both the same color. They both have a red and a blue wire. Of course, I know I've got the right one because if I had the wrong one, the freeze frame would be clear and it wouldn't work properly on play. So now I just have to do the alignment, get the tracking set up on here. Of course, my scope probe decided it did not want to work, so let's try a different one here. My old ancient probe was not passing a signal. So I'm using the garbage probe off my Chinese digital scope, which is, it's a horrible scope probe. Yeah, my little Tektronix probe here has decided it's no longer going to pass the signal. I don't know what's wrong with it, but it's not doing anything. I touch it and I don't see anything when I touch it. See? Like when I touch the end of this probe, I should be seeing signal, and I'm not seeing anything. So that probe has had it. So I'm gonna have to use this other piece of crap. That's because that SLHF300 guillotined my other probe. It broke off the clip off my other probe. So this one here, of course, got lots of signal. So I'm gonna have to use this cheap piece of crap probe, at least until I can get down and pick up a couple new ones. And they're not cheap. Half decent scope probes actually are quite expensive. So we'll clip the probe on to the RF test point and take a look at the RF and tweak it up and make it look good. So the adjustments I'm going to be doing is exit side guide and the entrance side. I'll let you see the scope. We'll get this thing in ship shape. So right now, this is how we're starting. You can see that our signal is dipping down. I'm going to adjust that exit side guide to make that pretty flat, and then I'm going to go over to the entrance side and adjust that one. Try not to slip and hit anything. Oh, look at that. Geez, like a quarter of a turn. And I think that waveform is about as close as I'm going to ever get it. The picture looks great. I'll show you guys the picture. There it is, playing on the plasma. Some dropouts on the tape. Hey, looking good. I don't think I could ask to get it any better than that. So I'm going to call this one a success. I got to get this thing back together. And well, I did have to raid my vintage collection of beta machines with spare heads on it. I did have to raid my spare machine to get this one going. I'm going to have a little chat with the guy that owns it now, because I don't just give away heads for free, especially when they're rare like this one. But this machine's now functional. As I say, I'll be talking to the fellow that owns this thing, and I don't know what happened to the other one. I'm pretty sure I didn't touch it when I took it out. I was very careful to keep my fingers away from where the heads were, so I didn't touch it. But one of them was definitely not working, and had to swap it out. Here's the original one, and as you can see, that head there is damaged. So what I think happened on this was, when this was stalled out and the tape was moving across here with the head not moving, the tape tension pulling on the head caused it to break, because as you can see, they are very, very fragile, and you can see that one is definitely broken. It's not broken off, but it's fractured. And now my camera doesn't want to focus. Come on, camera, you can do it. You can focus. But you can see it there. You see, it's broken. Actually, it is broken, but it's not broken off. It's just cracked. But anyway, that's one head. The other one over here looks okay. You see, that one doesn't move. So this one is bad. The first one I put on was this one here, and it's not damaged, right? The heads themselves look fine, no problem with them, but I couldn't get any signal out of them. So obviously well, I got signal, but I got very low signal, so obviously these ones are worn. And that's probably why it was in a donor machine and the wires weren't soldered, because I had already swapped the head at one point to fix another one, and I left the wires detached. Probably to remind myself that the head had been swapped and it was no good, and then I forgot. Anyway, I'll get this one reassembled, and then I'll do a final test. I'll take a look at it on the CRT monitor as well. So the rotor guard back in place. This is to prevent wires that are in the bottom here from making contact with either the capstan motor or the drum motor. So that keeps the rotors from making contact with wires and wearing down wires. So throw the screws in the bottom here. And get this one back together. This one's been on the bench far too long today. I don't know how long I've been on this thing, but it's been a few hours, probably 3 hours. I thought it was going to be an easy one.
That's right, easy. Nothing's easy when it comes to these old Betamax machines.
So there it is playing on the CRT monitor. Other than the odd dropout, which is a tape. Looks great. No problem there. Also looks great on the plasma. I always like to check them on both CRT and plasma because sometimes analog displays will display faults that won't show up on the digital displays. Like if there's excessive jitter, etc. Always shows up quicker on an analog display, although I put the scope on here so I knew the waveform was good, and the tracking is right dead center. And this is playing a tape that was recorded on my SLHF300 and it's looking good. So I guess we'll call this one a success, even though I did have to put parts in from 2 other machines. One that was supplied by the guy that supplied it, and that was the drum motor itself. There's the reason that it wasn't spinning, was the drum, probably the drive IC went bad and one of the 2 phases was missing, so the motor wouldn't spin. Could have been the Hall effect too, because that could have caused it, because if it doesn't detect the magnetic field changing, it won't switch to the other phase. So it could have been the Hall sensor or the chip, but one of the 2 caused this motor to fail. And I'd say this was the one that was in a couple months back to have that gear repaired on here, which of course is fine. That's not the problem. The problem was it stopped. But anytime the drum motor stops on these, if you fast forward or rewind a tape or do anything with the tape moving, when the head drum is not turning, you run the risk that the head is going to get damaged, just because the tape, and I can demonstrate this with the other drum. Okay, the tape, as you can see, look at this worn drum, this one here. But the tape's passing at an angle. So you can imagine if the head is stopped like it is right here, if we look at the head is protruding through the slot in the drum. And if the tape is being pulled around there, normally it's spinning. And when it's spinning, there's no friction between the tape and the head, because the head is spinning at 1800 RPM for NTSC. What will happen if the drum stops is, if the tape is being dragged across here under tension, the vertical shift, or the vertical, I guess it's the vertical shift of the tape pulling across the head, can damage it. And I think that's what happened on that one, is the tape being dragged across there, either in fast forward or rewind or whatever was done, damaged one of the 2 heads. Anyway, new head installed, or I shouldn't say new head, a used head from a machine that I'd already been picking parts off of. I thought I picked the regulator off my 900, but it looks like I picked the regulator off this one, and I can say that with confidence because it says STK 5441 robbed for SL1000. So this machine's had a bunch of parts. I've already picked the I've already pulled the gears off this to fix other machines, so this was a parts wrecker. Now the heads have been pulled off this one as well. So that is it. Thanks for watching. We'll catch you later in the next one, when I put up the other one that came in, which is an SLHF 750. That will be going up next, and we may be using the video head. If it's the same one that I had before with a worn Beta 1 head, then the disc might be coming out of this one to fix it. We'll see. And to answer your question about whether a 3-head machine can, or 3-head disc can be replacing a 2, yes. The 3-head machine just has 2 heads side by side. So there's 2 wires going up, one for the A or for the B, and 2 wires going up the other for the A. But they're just 2 heads mounted on the same chip, or the same support, that are side by side. And that's just used for slow motion and special effects. Other than that, that 3rd head is never used. So this machine doesn't have circuitry to process 3 heads. It only has circuitry to process 2. So we leave the 3rd one disconnected. Everything's fine. Just to clear that up. Thanks for watching. We'll catch you in the next one.